Good afternoon, everyone. My name is TJ Willits from Veolia Water Technologies, and I'll be your moderator for today. I'm just looking at the sign-in panel here, and it looks like there's some people still logging into the webinar. So we're going to wait a few moments here and allow them to get settled before we begin the presentation. So just hang on for a couple minutes. Thanks. And for those who just may have logged in and are joining us here, we're just going to give it another 30 seconds to a minute or so before we start today's broadcast. Okay, again, welcome everyone. My name is TJ Willits with Veolia Water Technologies, and I'll be today's moderator for the presentation. We're real excited to pick back up on our anaerobic operator webinar series. And today's topic is entitled The Most Common Operational Challenges for High-Rate Anaerobic Systems. And just some housekeeping things to go through. You should obviously be hearing me speak now. If you're having issues with audio throughout today's broadcast, you can also switch between computer audio or phone call and use the dial-in if you need to use the phone call if you're having issues with your computer audio. Just a reminder that today's webinar is being recorded, and people who attend and those that are even registered and didn't attend will receive a copy of the recorded version of today's broadcast. Another thing to remind you is that we have our question panel open. If you go to the right hand of your screen, you'll be able to interact with today's panelists that we have for you here. And just go ahead and log your question in there, and we have some time at the end of the broadcast where you could, we're going to get to as many questions as possible. After the webinar, you'll be given a chance to fill out a survey. The survey is great because it helps us shape the content for future webinars. So feel free to go ahead and enter any ideas that you have in terms of things you might want covered or things that you're having issues with or challenges that you want our experts to talk about. Also, everyone who has registered for the webinar will automatically get a participation certificate. However, sometimes people are watching this webinar with other people in the same room or office. And if you're doing that, can you just go ahead and put their information in on the survey, and we'll try to get them a survey or a participation certificate as well. Okay, we're going to start today's broadcast by introducing our two panelists. With us is Jill Jordan, who is a senior process specialist with Veolia. And Jill, who you may have experienced on the past several webinars, she has over 35 years of experience in anaerobic treatment. She commissioned the first high-rate anaerobic reactor here in the United States many years ago, and just has been supporting Veolia's high-rate anaerobic digesters here ever since then. Also with us is our operations manager, Jack Kuhar. He's been with Veolia for over 10 years and has served in a variety of roles, including project engineer, project manager, engineering manager, and now operations manager. He's been instrumental in the design and engineering, procurement, and implementation of anaerobic processes. So we'll be excited to hear a little bit more about him later on in the webinar. So at this time, we're going to hand the webinar over to our first panelist, Jill Jordan. Jill, are you with us today?
Yes, I am. And thank you very much, TJ. So in today's webinar, we're going to talk about several things that general operating problems, mechanical issues, operational issues that everybody sees in high-rate anaerobic systems. We're going to start off talking a little bit about safety, just a reminder to everybody, then things about instrumentation and controls, then operational issues and mechanical issues. So Safety and anaerobic digestion systems. There's a ton of confined spaces in wastewater treatment plants, in anaerobic wastewater treatment plants, not specifically, but in general. Always be aware of them and follow confined space entry procedures. High rate anaerobic systems generate biogas. Biogas contains flammable toxic gases and has no oxygen. Make sure you wear your gas monitors and make sure there's no smoking in the area. Also, not only the biogas lines can contain biogas, but so do the effluent lines. Also, there's a lot of rotating equipment around that you have to be cognizant of, as well as you could be splashed. You need watch out for, just make sure you wear your PPE and everything should go well. So instrumentation and controls. Let's talk a little bit about how they can affect your system's performance. Instrumentation. I'm going to start off with pH because I hate pH. It's a real pain in the neck, but so very important in anaerobic digestion. It's so important that the digester pHs are right in the optimal range of 6.8 to 7.2, and therefore the pH is controlled in all of our systems. But the pH probes need to be checked and calibrated regularly so that you can ensure that you don't over or underdose chemicals. If you over or underdose pH control chemicals, it could result in a catastrophic event in your digester. We always tell our operators during training at startup is that they need to collect samples from every inline probe daily and check them with the against the calibrated lab probe. And if the deviation between the lab measurement and the inline measurement is more than like 0.2 standard units, then you need to clean and maybe calibrate that probe. pH problems have caused more system upsets and failures than any other thing that I've witnessed in the past 40 years. I can't tell you how important it is to maintain this equipment properly. There's other types of instrumentation that are commonly found in anaerobic plants: temperature control equipment, flow control equipment, pressure and level measurements and controls. Now, generally, temperature and flow instrumentation is pretty reliable and really doesn't need that much attention, but you should still check it regularly and have it on a regular maintenance list. I can't tell you how good an instrument tech is to your system. They're invaluable. Let's talk a little bit about level and pressure, because they're really sort of related a lot of times, because they can cause you some issues. As you see the picture there on the just to the left, that's a DP cell in a tank. It's properly heat trace and insulated and isolated. I can't tell you again how many times I've seen in cold climates where these DP cells have frozen. This results in an erroneous level reading, which is usually used to control something, which then messes up your controls. That can result in a tank being drained and or overflowing. Not a good situation. So always make sure that you have good, proper freeze protection on this type of instrumentation in the winter. Also, make sure that it's calibrated properly. If you take a DP cell and it's calibrated for water, which has a specific gravity of 1, and then you put caustic in the tank, which has a specific gravity of 1.5, it's not going to read properly. So make sure that it's calibrated. Similarly, gas pressure sensors. Moisture in the biogas lines can foul these and cause a false reading. This could potentially result in an overpressurization of the digester, which would release biogas to the atmosphere. Again, not a very good situation. So make sure that you drain the level transmitter itself and the drip traps to keep condensate out of the lines. Controls. at most of our high rate plants, you're going to control the pH, you're going to control flows, you're going to control levels, you're going to control temperatures. And you have to make sure that these control loops are operating properly. You could have, when we go through startup, we set these up and everything's good for that condition. Now, that doesn't mean that your wastewater doesn't change throughout the years. So you may have to change these setups. You may have to change the PID loop readings, the P, the I, the D, to make sure that it can then work properly under the new wastewater conditions. Also, oftentimes you're doing some work and you need to run a loop in manual. You have to make sure that you put that back in auto. Any control that is supposed to be in auto has to be in auto and should never be left in manual. Again, you can have an upset condition because something is in manual. Again, as a pH is an example. I've seen instances where they've left the pH control in manual after calibrating a pH probe, which resulted in caustic being continually sent into the digester over time because the pH that it was reading was below the set point, which resulted in killing and inhibiting the bacteria in the reactor. Again, make sure everything's back in auto that when it's supposed to be in auto. Alarms. All of our parameters, I should say all, 99% of our parameters also have alarms associated with them. And when we do a startup, we try to make these alarms so that they're not a nuisance alarms. There's nothing worse than a nuisance alarm in my book. In our systems, we allow the operators to adjust the the alarm set points for the high, the low, the high, and the low alarms. And one thing that you have to be especially careful of is if you change a set point in your control parameters, you want to make sure that you adjust your high and low and high and low alarms associated with that parameter. If you don't do that, you could miss out on a potentially dangerous situation. So make sure that you change your alarm set points based on what your control or operating set points are. Don't ignore the alarms. TJ, go back, please. Thank you. Again, the high and the low alarms are there for you, the operator, to make sure that you take a look at what's going on before it gets really bad. If things get really bad, we often put high and low alarms in there, and they're usually associated with some sort of interlock, which should shut the system down before things get really bad. But again, you have to make sure that these are set points are set properly so that they're not nuisance and that they work and will protect the system if necessary. Okay, TJ. So operational issues, what are some of these that we might have? The most common operational issue is sludge loss. And what are the reasons for sludge loss? The first one is influent wastewater characteristics. And I'm going to talk about those, then we'll talk about some mechanical issues such as clogged settler maintenance, mechanical issues, and feed distribution issues. But let's talk about the wastewater characteristic problems first. Fats, oils, and grease in your wastewater can cause sludge to float out of the digesters. Make sure that the FOG level in the influent is less than 50 milligrams per liter. If it's not, you want to put some upfront FOG removal, such as a DAF. Again, FOG, very bad and the most common reason for sludge loss. Remember, fats and oils float on water, so they're going to grab onto the granules and float them out of the digester. High influent TSS is also a problem, and it can wash out biomass. When we look at the correlation of what's most highly correlated with high effluent TSS, it's the level of influent TSS. So the higher the influent TSS, the higher the effluent TSS. So we want to keep the influent TSS less than 10% of the total COD, or hopefully less than 500 milligrams per liter. If you can't keep it that low, we recommend that you would put some sort of upstream solids removal. That could be screens, it could be clarifiers, centrifuges, a DAF. You can also put in an influent TSS or a turbidity measurement to divert high TSS influent into a calamity tank if available. High COD loading can also result in a loss of biomass. And why is that? Because high COD loadings result in high gas production, and high gas production rates are the second highest parameter associated with high effluent TSS. The higher the gas production, the more solids that are going to wash out. So if you have high influent COD, you can make high gas production. How do we solve that? Again, we can put an inline influent TOC or something, maybe a Brix monitor, something that tells you in the influent that the COD is higher, and then divert that if possible. Toxic substances can also cause the loss of biomass. And the most common toxins are quaternary ammonia, peracetic acid, any oxidizing compound, hydrogen sulfide, bactericides, and biocides are also toxins that can cause biomass to wash out. And why does it cause it to wash out? Because it usually dies, it sloughs off the granules, and then you lose biomass. How do you prevent this from happening? The easiest way to do it is don't permit the use of toxic or inhibitory substances in the factory. Test any new product that might be used in the factory, mostly CIP chemicals or boiler cleanout chemicals, things like that. Test them for anaerobic toxicity. And if they're going to be really toxic to the anaerobic biomass, look for some other chemical compound that might do the same job but won't be as toxic to the anaerobic bacteria. Have a communications plan with the production and sanitation teams in the factory to quickly report spills and abnormal material disposals. I can't tell you how important this is. Historically, it's always been, if I spill something in the factory, I'm not telling anybody because I'm going to get in trouble. You have to try to change that around so that they get in trouble, so the people know that they'll get in trouble for not telling that these things happen. Oftentimes, if something happens in the production facility, there's a spill, if you call the wastewater treatment plant, they can make plans, divert, do something that would help to prevent those potentially toxic compounds from killing the biomass. Okay, I think I'm going to turn this over to Jack now, who's going to talk about some of these mechanical issues that can cause sludge loss. Jack?
Hello, everyone. So I'll take it from here. This clogged settler is a thing I've seen a bunch of times going out and do site inspections. So as you know, this is our three-phase separator in the top of the digester, separating the gas, the water, and the biomass sludge. So when these settlers are clogged, you get less surface area for the water, gas, and sludge to flow over, and it increases the velocity. So that increase in water velocity causes the three-phase separation to not work as well, so then you can get sludge loss coming out. So here you can see two pictures of some clogged settlers. That, looking down in that one, it's just filled with black gray solids there. That should be open. You should be able to kind of see down in there further. So these settlers are extremely clogged. So how do you prevent this? Well, most of our tanks have a top sample port coming from the top of the tank. So you can check in there to make sure your sludge bed has not grown up high into the top of the tank. We also have the sludge sample ports to various heights inside the tank from the bottom. So that's another way, monitoring your sludge bed height on a frequency. I can't remember what we prescribe in our manual, probably every 2 weeks or every month at least, to make sure you don't have sludge that's growing high up into the tank. So unfortunately, there's not really much you can do though to fix a clogged settler besides taking the system down. So if this does happen, then you need to plan a full shutdown and clean that settler out, usually washing it from above or building scaffold from below and pressure washing it and sucking it out with like a vacuum truck. Next. So mechanical issues could also be the cause of sludge loss in the settler. So is there a break or a leak in the settler? The settlers in pretty much all of our tanks are connected from the settler wall to the tank wall with piping or flanges. And this is a common area where you can get a leak. So we've seen many plants where just a small little leak in this flange here or this pipe can result in significant sludge loss because the sludge just finds the easiest path or least path of resistance and gets out of the tank. So if you're doing outages, this is always a good place to inspect. Or if you have a sludge loss issue, you can troubleshoot and try to figure out if this is where the leak is happening by looking at the levels inside the tank, shutting it down and seeing where the level goes down to. So again, how do you prevent this? Well, some type of planned maintenance or inspections, tightening these bolts. Our standard is to provide double nuts or lock nuts on any flanged or bolted connections inside a tank. So that would help there. But if you're going inside the tanks, make sure these connections are tight, replace the gaskets after several years. Okay, feed distribution. So this is the piping in the bottom of your tank that distributes the water across the floor. So why would we have feed distribution issues causing sludge loss? Well, you have heavy sludge at the bottom. So you have this buildup of inert material in the sludge bed, resulting in a VSS concentration that's not ideal. So how do you prevent this? You got to keep track of that. That's in your sludge sampling procedures that you do on a frequency defined by our operation manual. So you're measuring the TSS and VSS in your tanks and how high that sludge is up in the tank, and making sure you remove biomass from the bottom to control the buildup of inert material. So what else? Clogged nozzles. So if you ever shut this feed piping off and don't close the control valves or manual valves outside the tank, your biomass can migrate back into the piping if you have a path of resistance backwards into the piping system. So this could cause clogging of these feed nozzles. So you can look and see that one picture shows a little header pipe on the floor, and there's a little branch pipe with a nozzle coming out the side. So there's an orifice there, and that orifice is smaller. That creates the pressure drop that distributes the water flow along the length of that pipe. So you have a smaller orifice there that can clog if you don't have continuous flow out there, or if you have backwards flow. So ways to prevent this is the header checks. This is another operational procedure we prescribe in our O&M manual. So that's usually every couple of weeks or a monthly procedure to blast water through each individual header to keep them clean and prevent solids from entering the feed pipes. So again, you can help with the TSS coming into your system, trying to remove it before it gets in the tank. You can remove your biomass, like we said above, to prevent the buildup of inert material. Also, if these things get clogged, we have a example procedure of jetting out the feed piping from external to try to clean it out. So I believe we've provided that to some customers before. Some people have tried it and it's worked, others it's not. So if you can't get it to be unclogged from header checks or external cleaning, then this is another thing you have to go in to clean out with a shutdown. Okay, some more mechanical issues we'll go into next. Okay, equipment maintenance. So there's a lot of stuff in our facilities, our wastewater treatment plants. So having routine maintenance is critical to keeping the system running and running reliably. So lack of maintenance, failure of equipment, that can result in downtime, loss of biogas for use, having to flare it, environmental damage, increased sewer charges. So really maintaining your equipment is important. So that's an example maintenance schedule for a standard centrifugal pump. So we provide all the maintenance requirements for our equipment that we provide in our manuals, our equipment manuals, when we supply a new system. But it's important that operations and maintenance departments, go through all that equipment and develop standard maintenance procedures and intervals so you can prevent unplanned outages and downtime of the equipment. Next. Corrosion of our fiberglass top works. If you have a removable roof style digester, there's fiberglass components up in the roof, and these are in the top of the settlers. So there's beams and troughs and weirs and scum bars. They're all fiberglass components. And this style of digester has these aluminum removable covers. So you can see here on the right, there's two pictures of some damaged fiberglass. So that one beam that's kind of broken and fallen, there's a scum bar, scum plate there that's delaminating. So this stuff is mostly submerged under the water, but there are parts of it that are sticking above the water level, and that water level is slightly corrosive because you have still some dissolved H2S, CO2 in that water that's coming out of solution, mixing with the atmospheric air and causing acidic type conditions. That fiberglass is the best type of component up there, but it still has some lifespan. So typically it's 10 to 20 years. So really you want to be looking at this stuff on a daily basis, not daily, sorry. You want to be looking at this stuff whenever you're going up and doing your rounds on the top of the digesters, if you're cleaning weirs out, and make sure you don't have any signs of deterioration, because again, you won't be able to inspect the tops of the reactors if all the beams are starting to fall in, because you won't be able to walk up there. So again, try to replace these things before there's a structural issue or a safety issue that you can't even be up on the roof. So here's a gas holder. This is a can style gas holder. There's two tanks, one inside the other, with a ballast system that's floating in the water that has biogas in it. So this is a buffer tank for the gas to help control the gas flow and keep a constant pressure, back pressure on the biogas system. So we've had some issues. Clients have notified us over the years. The adder tank may experience some corrosion over time at the water level line. There's heating coils for when we have these tanks installed in colder climates, so they start to get corrosion if the makeup water, there's seal water, makeup water in the bottom of this tank. And if that water is sediment, it all kind of will accumulate in the bottom of the tank and cover that coil and cause, under deposit type corrosion. So again, this is a maintenance and inspection type of thing. Take this gas holder down when you can, empty it out, clean out the bottom, inspect it for corrosion repairs as needed. A lot of the older ones we did were coated carbon steel, so you got to inspect the coatings as well. Some of the newer ones we've been doing are all stainless steel, so you don't have to worry about coatings as much. But again, you still need to look for mechanical wear and potential fouling in the bottom from the makeup water. Next. Okay, this is a more recent one that we've been seeing. It's corrosion in these blow-off chutes and standpipe piping. So that little cartoon diagram there is a blow-off or overflow that we put on a sealed top EGSB type digester. So that's usually a stainless steel tank and a stainless steel pipe there. And you can see it's there's a dip pipe that goes below the water surface, and there's biogas space above that water level, and it's water sealed to prevent the biogas from coming out. But above the water level in that pipe, where it's atmospheric, again, if you have high H2S in your water, you get a corrosive atmosphere in that pipe, which can form an acidic condition. And even with that pipe as stainless, over time, you can get a corrosion that recurs at that air-water interface and results in a hole. So we've had a couple clients actually inform us of this the last couple years. Actually, this last year we had one. So that can create a dangerous situation because you'll have actually a biogas leak out to the atmosphere. So we've seen people put either polypropylene or PVC liner and shove it down inside that pipe and seal it off to isolate the stainless steel from the corrosive vapor space. The picture down below too is if you go back one more, that's a effluent pipe coming out of a digester, and the water was most likely flowing half full. So you had a vapor space in that pipe with water on the bottom. So a corrosive vapor space above the water level that corroded the pipe. So fiberglass roofs, there's a lot of the old jobs. We used to put fiberglass roofs on these tanks, and we're not doing that as much anymore. It's usually epoxy coated carbon steel roofs, and those epoxy coatings have become very robust and better over the years. So we don't do fiberglass roofs too often anymore, but a lot of our old tanks had these fiberglass roofs, but again, they have a lifespan 25 to 30 years. So you should be doing inspections on these roofs and look at them and replace them before they fail. This is an example of one that failed while it was online. The system was still online. So you can replace it with fiberglass again, because they do give you a nice long lifespan, or aluminum geodesic domes are another good option. But again, if you're not replacing the roof in kind, you have to look at the loads from the new style roof and see if the tank can handle it. Also on these tanks, there's, like with EQ tanks and conditioning tanks, that don't have a constant level or not at a high level, have a PVC liner, like a thin sheet PVC liner that scrapes down the inner sidewalls of the tank below the normal operating water level. So that's like a corrosion barrier for the tank walls. So those liners will fail over time. Again, a 10 to 20 year lifespan we've seen. So that's another thing you should be inspecting when you go in these tanks. So next, clogging of heat exchangers. So whether you have a heat exchanger or not, they are vital to ensure the optimal reactor temperature. And if they're starting to clog, you're going to get either less temperature or not enough temperature. So again, our standard design is to have some specific piping to flush these heat exchangers out, whether you have a plate and frame or a shell and tube or a spiral heat exchanger. We recommend some manual piping here, as you can see in this picture, to be able to reverse the flow through it. So you want to make sure you're keeping the system from fouling, and make sure your influent and solid systems are removing solid systems, so you don't have too much TSS coming into these things. We would recommend CIP cleaning connections, so you could isolate these heat exchangers and kind of put like a little chemical cleaning solution into them and run it around in a loop for a little while. But that will help you keep your system at the right temperature and make sure you don't have excessive fouling and heat exchanger clogging problems. Next. Okay, caustic injection. So some of our older facilities have inline pH injection into the reactor feed piping, and usually it's caustic. So this works in some places and sometimes it doesn't work, or it doesn't work over time. So you can get local fouling and scaling at that injection point from the caustic addition. So if you're having this problem, we've helped clients to relocate their acid injection points to a mixed tank or a rapid mix tank or a conditioning tank, or added another tank like a wide spot in the line just to do some rapid mixing of chemicals. And this helps, well, it does help control the pH a little bit better when you have a bigger injection point. But again, as Jill said in the beginning of the presentation, pH is very critical. So if you're having these concerns with your caustic injection point, this could be a good thing to look at. So we got gas piping. Again, this is a common problem with cold temperatures, and with the cold temperatures we've seen all over the country recently, this kind of is a good time to talk about it. So the gas line and PRV and flame arresters can get clogged for a couple reasons: foam, or the buildup of condensate or freezing piping PRVs. So first off, if your system is not heat traced and insulated like these pictures show, we highly recommend you do that. Again, follow the recommendations of the PRVs and flame arrestor manufacturers and regularly inspect these and clean them, especially after an incident like foaming. Draining drip traps is a regular daily routine you should be doing, and make sure you drain them till empty. So, and then draining sensing lines on a back pressure regulating valve, and draining any drip traps, low points. Just make sure your biogas pipes are flowing open and not frozen from water. Oh, this is a fun one too, chemical feed pumps. So I don't know if you have a lot of these type pulsafeeders, or let's see, Milton Roy's or Prominent pumps. We've been doing a lot of those type of pumps in the past. And these little chemical pumps are really essential for pH control and nutrient addition. So, but they can be difficult to maintain prime, maybe based on how it's installed, too much suction lift, too much piping, tubing leaks, whatever it may be. So this is something you guys got to pay attention to. Make sure your tubing connections are tight. Make sure you have a suction piping and foot valve into the top of a tote or drum. Make sure that's all working. Really, you should, if you can, connect the suction into the bottom of the tote and make your tote higher than your chemical pump. If you're using, say, a pulsafeeder, Milton Roy, Prominent type pump, to give them, some suction head, so they don't have to lift it up as much. They can do some slight self-priming, but they're just still not the best. And recently we've been changing a lot of our pump supplies to these peristaltic hose type pumps you see there. There's like Watson Marlowe, blue white. These pumps are nice. They have a wide turn down ratio, plus they self-prime to very high lift, head lifts. So there is some more maintenance with them because you got to change that hose on some frequency, but they can help avoid a lot of the operational problems with those diaphragm solenoid driven pumps. Level sensors, so sludge tank level sensors, we've seen a lot of problems with these, whereas we used to use ultrasonic a lot. And in sludge tanks, you have a kind of a hot fluid with moisture and vapors from the sludge. If you ever fill the sludge tank too high and you get solids on the sensor, both moisture and solids on that sensor can really disturb an ultrasonic reading and cause that to go crazy. So radar has been a good solution. So if you have some old ultrasonic readings or level sensors in sludge tanks, or tanks with a vapor space that has moisture in it, you may want to consider switching to radar, because that will be a much more reliable level reading. Next, biogas flow. So again, this is something in the last 5-7 years. We used to use these thermal mass flow meters. They were pretty much the industry standards for biogas. But again, they're very sensitive. They have to be installed right. They have to be heat traced and insulated like crazy, because if you get moisture on that tip, they don't read right. So the past, again, 5-7 years, Anderson Hauser's come up with this ultrasonic biogas flow meter called the ProSonic B200. It's really nice, very reliable. I mean, you have to heat trace and insulate it, but you don't have to worry about it. It's just a flanged connection. You plop in the pipe. But it also has the capability to measure methane content, which is a very nice feature for the operators. So you can actually measure your methane yield versus just calculating it based on the COD. So this is really nice, these flow meters. So if you have having problems with your thermal mass flow meters, we would recommend upgrading to these style flow meters. Electrical boxes. So there's a lot of electrical boxes out there in the wastewater treatment plant, and they're often in wet locations. So make sure these things are closed and sealed, especially before you're cleaning something or washing something down. You can see this picture on the right. There's moisture dripping from the top. You can see this, all the rust all over this electrical box. So that can result in some wiring issues, electrical problems, reliability of that equipment. So make sure you have the right seals and aren't getting water into your junction boxes or control boxes or instrument connections. Hazardous locations. This is another one. So areas with biogas around the reactor, we classify those as hazardous locations. There's a standard called NFPA 820, which is fire protection in wastewater treatment plants. So you have to be sure that if you're, say, adding equipment into these new, upgrading your plants, adding equipment, doing a project, you make sure that these regulations are being followed with proper electrical equipment and classifications. So, way back when, we didn't have a lot of these requirements. So biogas plants got built without a lot of the seal offs or explosion proof fittings or junction boxes or seal offs, conduits, things like that. So again, check the requirements of these codes, check with local codes, make sure your plants have these hazardous or following these hazardous area classifications, class 1 div 2, class 1 div 1. If you're doing capital projects, make sure you're getting new equipment with following these requirements, because it's a safety issue, and it always helps with insurance requirements too, owners insurance requirements following these standards. So that's it.
Okay. Thank you, Jack. Thank you, Jill, for going through those different areas. It seems to be quite a catalog of experience that both of you probably seen out in the field. So I'm sure all of our attendees appreciate you sharing that experience. Just a reminder, we're going to enter into our Q&A time. If you have a question, feel free to go and enter it on the question panel on the right hand of your screen. We've got a few already. We're going to start to get into those shortly, but go ahead and enter that in, and we have enough time here probably to get through most, if not all, of these questions. While you're entering them in, we did receive a few during the presentation. The first question we have is for Jill. Jill, what is the recommended way to test for toxicity on new CIP or sanitation chemicals?
Thanks, TJ, and thanks for the question. There's standard toxicity testing that our lab does and several other labs around the country do, where you just send the new chemical to, like you would send it to us with the intended use rate, and we can expose it to anaerobic biomass and determine if it is toxic, at least if it has any acute toxicity, by measuring the COD reduction in biogas production over various concentrations of that. After exposing the biomass to various concentrations of that particular chemical.
And a follow-up question to that, Jill, is it common for sites to ship their sludge for it to be tested with their specific sludge?
I think you mean sludge with chemical. That's not necessary. We have a bucket of fresh sludge that we keep in our lab, so that we would expose that chemical to that sludge that we know to be good. We can also test sludge if you send us a sludge sample and do an activity test on it.
Okay, thanks, Jill. Another question is why does the VSS wash out of the digester when the COD loading rate is high? And the follow-up question to that is it due to granule size that reduces with loading rates, or gas bubbles that stick to the granules?
I don't know that it's either of those. It's just that sometimes with a smaller, it does have to do with particle size. Sometimes the smaller, I'll call them embryo granules, or they're not even granules yet, they're more flock. The flock doesn't have the settling velocity that the granules have. Therefore, when the gas velocity comes up with a higher loading, they tend to wash out. It's actually one of the pressure parameters that is used to make sure that only the granules stay in the reactor. We want those flocks that don't form granules to wash out, and that only the granules stay in at the higher gas velocities. But you'll notice when you have changes, like if your reactor doesn't work on the weekends, the gas production goes down. You'll notice oftentimes that on Monday, Tuesday, when the gas production comes up, you'll have higher effluent TSS for a couple days before things settle out again, because of the lower velocity on the weekend and then the exposure to the higher velocities on Monday, Tuesday. But it's really a gas velocity issue.
Another question is if the plant communicates a spill in chemicals or an unknown substance and it gets routed to a calamity tank, what is the best way to handle that influent wastewater in the calamity tank?
Depends on what's in there. I hate to say that. If it's just high COD, if they've had a spill of a product, that can be bled back in. If it happens to be a toxic chemical, let's say you have 1,000 gallons of quaternary ammonia compound or something like that, it's going to be toxic, and you have to find you would have to dispose of it through a hazardous waste facility, I believe.
Okay, thanks, Jill. Well, that's it for our questions. If there's any other questions, feel free to shoot them myself or Jill or Jack. Just want to take this opportunity. We already have a date planned for our next webinar, our Q2 webinar. That's scheduled for May 19th. It's a Wednesday. The current topic that we're considering is new permit limits, considering direct discharge, enhancing wastewater treatment process to help with those changes, those permit limits, or if you're looking to go to direct discharge. We'll talk a little bit about how you could retrofit your process to account for those changes there. So we hope that you'll be able to join us for that webinar. And of course, be on the lookout for that email communication from us and register when you see that. Also, just want to remind you that you'll be presented with a survey upon exit of this webinar. Take those few moments to fill it out. It's only a couple questions. And also, if there's someone that you're with in the room that needs a participation certificate, that's how we'll be able to know to go ahead and send that to them. I want to thank both of our panelists, Jack Kuhar and Jill Jordan, for taking time and preparing this presentation. And again, we're here to support you, our customers there. And if there's anything that we can do to answer any additional questions, please feel free to reach out. Don't hesitate to send one of us an email, and we'll get back to you as soon as possible. Oh, we did get one more question. Jill, might as well have this answered here. Is the biomass specific to the type of wastewater?
Yes, the biomass is specific to the wastewater generated at your factory. So even though we have plants, let's say at 15 different breweries in the United States, the sludge from each brewery will be different slightly. although it's, you know, you could use one to the other, but they'll all be slightly different depending on the exact type of beer and products and yeah, ingredients that they're using in their beer and what gets into the wastewater, including the CIP chemicals. So yeah, although you can use biomass from a pulp and paper mill to seed a brewery or vice versa, you do have to go through some adaptation before it converts to your type of sludge from your specific facility.
Great. Thanks so much for sneaking that last minute question in there from one of our attendees there. Again, can't thank everyone for joining us. Can't thank our panelists enough for preparing it. I just want to wish everyone a great rest of their week and look forward to see you in a few months here. Take care.